Hi, my name is Nick Pashis, and this is my project presentation for picking an optimum team for daily fantasy hockey contests. So first, just some background on daily fantasy sports leagues. In a daily fantasy league, contestants will choose a new team each day, and they will lock in that team by the end of the day. Then on the following day, actual hockey teams will compete in the NHL, and those daily fantasy teams will be awarded points based off the real life player performance in the NHL. On the right, there is an example rubric for how real life player performance translates into points. You can see that players earn points for doing things like getting goals, assists, shots on goals, and goalies can earn points in a similar fashion. I will be looking at the double up payoff structure of the fantasy leagues, which means if your team finishes in the top 50% of all teams, you will be awarded a cash prize, which is roughly double what your buy-in cost was. And it's important to note that only an estimated 20% of players use sophisticated picking techniques for team building, which means there aren't enough of them to, make sure that you still have a chance. So I will be trying to pick the optimum daily fantasy hockey league team through treating this as a 0-to-1 knapsack problem, in which the objective function will be maximizing the average points per game. The objects are players, the weights are their salary, their values are the average points per game, and they are also subject to a salary cap constraint, which is set at 50,000, and also lineup requirements. Each player has an associated position, and the limit set on how many players you can have of each position type is shown on the right. Shown on the right here is where I pulled my data from. This is a roster published by DraftKings for their daily fantasy sports league. This roster is based off of who is playing on the next day. It will typically include 200 to 300 players, and I imported this into MATLAB, and this is what I used to run my code. Here's my basic plan for how I wanted to approach this project. I wanted to first make a working branch and bound method code in MATLAB. I then tested it on homework and a few example problems. I then adapted it to work for a daily fantasy hockey league, and then I determined how well it did in the daily fantasy league. And right before I move on to my results, I just wanted to show you the outline of my code. This slide shows the results of entering the output of my program into one daily fantasy sports league. On the top left, you can see that the weight is equal to 50,000, which means that the team is at its full salary capacity, and that it only took just over 2,000 iterations to get to the optimum solution, and it took less than half a second. The bottom right chart shows the optimum team that this program picked as it appears on the roster. And this team was competed in a daily fantasy contest, and it finished ahead of 62% of the contestants, which may not sound like much, but it was more than enough to receive a cash payout. Going forward, I believe there are many paths. One would be to enter this program into many daily fantasy leagues to see how it competes over time. But the main area of improvement would be to update the objective function. Currently, it is based on only historical metrics, and ideally you would want an objective function that is predictive of future performance, not purely based off past performance. While there are many methods to do this, one possibility is maximizing the probability of attaining more points than other contestants. This can be accomplished via mean variance optimization.